In the last video, we were working on transformations, and we started looking at the vertex form of the equation. And so today we're going to actually explore the vertex form of the equation in more detail. First thing I want to point out to you, though, is this little section right here is taken from the reference materials given to you on the STAR test and on our district checkpoints. So it has our standard version, our vertex form, and something we'll be covering in a couple of days, the axis of symmetry formula. So just keep that in mind, because if you ever get confused on what exactly the vertex form looks like, or if you get confused about which one's negative and which one's positive, you can find it on the reference materials. All right, so given our vertex form, there's a couple of things that we can do. We can use the h and the k to find our vertex. We can also use the h to write our axis of symmetry. These are very helpful things. The biggest thing we had started to explore was when we were looking at it in vertex form. When we were talking about the translation, what was on the inside of the parenthesis, it was the opposite. So this would be moving to the right too. So we kind of have a little phrase or a little saying that might help you remember it, which is right up here, X lies and Y tells the truth. So if you think of X lying down, X is a horizontal line, X lies and Y tells the truth. If you use that idea, X lies, that means we need to take the opposite of whatever H we've been given. Okay, so let's look at number 1. And what we're trying to find from it is our vertex and our axis of symmetry. Let's make this a little bigger so we can see it. All right, so we're going to use our h and our k to figure out our vertex and our axis of symmetry. So we know we have an h here. We don't have a k, so we can say plus 0. It's not there. But if we go ahead and label it as a k and do the plus 0, it's easy to see. Our vertex is h comma k, but remember that h lies. So if h lies and we've got a negative 2 as our h, the opposite of that is positive 2 comma 0. So we already know from looking at this, it's going to shift to the right 2. That makes sense with our vertex being positive 2 comma 0. And then the other thing that we know for sure is our axis of symmetry is a vertical line that cuts the parabola directly down the middle going through the vertex. So our axis of symmetry is always the x value of our vertex. So we can look at it very quickly and say, all right, my axis of symmetry is x equals 2. Okay, so what I want you to do is to figure out the vertex and the axis of symmetry for number 2. So pause your video, figure out your axis of symmetry and your vertex for number 2, and then start it back up for the explanation. Okay, as long as you notice there wasn't a k and made it a 0 and took the opposite of your h, then you got this one correct. Now I'd like you to do number 3 and number 4 on your own. Pause your video. Once you've completed number 3 and 4, start it back up again for the explanation. So just like we did in the last video, we're going to look at the transformation of a quadratic. It's written in vertex form and how it has transformed from the parent function. So before we do that, I want you to pause your video and fill out what the a does to a quadratic, how it changes the parent function, what the h does to transform it, and what the k does to transform it. Once you have those filled back out, go ahead and start the video up and check your solution. So just check your answers and make sure that on the A you got that both the stretch and compression, the vertical stretch and compression, and the fact that if it's negative, it'll reflect across the x-axis. The H, make sure you put down that it's the opposite direction, and it's your horizontal translation. And then the K is your vertical translation. Positive is up, negative is down. Okay, so now we're going to graph this function, and we're going to describe the transformation from the parent function. So let's start by graphing it. So the first thing we need to know, if we're going to graph this thing, is what is the vertex. So to figure out my vertex, I'm going to say H, and then I have plus 0, K. So my vertex, X always lies, so the opposite of positive 2 is negative 2, comma 0. So I have my vertex, and by definition, I know my axis of symmetry is the X value of my vertex. So let's see how this looks on my graph. So I'm going to graph my vertex at negative 2, comma 0, and I'm going to graph my axis of symmetry. First thing I need to do is go ahead and just draw my X and Y axis so I can see them. Okay, so I'm going to put my X and Y axis right here. Give me some space. Okay, so there's my lovely X and Y axis. Now I can go ahead and start graphing my vertex. So my vertex is at negative 2, 0, and I'm going to do my boxes over here just by 1. So negative 2, 0 is right here. So on my x-axis, I'm going by 1s. On my y-axis, though, I think I'm going to need to go by 3s. So now we need to find a point. So let's draw our axis of symmetry. And all I need to do really is to pick one point. I could make a table and put a couple of points in here, or just even one point and use my axis of symmetry. So let's just work on getting us one point on here. So I'm going to pick a point of 0. Okay, so I'm going to, in my table, I'm going to pick a point of 0 and find out what my y value is. So I've got 3 times 0 plus 2 squared. So 0 plus 2 squared is 2 squared is 4 times 3 equals 12. So I have a point on here of 0, comma 12. So let's go ahead and graph that on my graph. Remember that I'm going by 3s on my y-axis. So 3, 6, 9, 12. So right up there is 0, comma 12. That's the point 0, comma 12. Now, the way we can use our axis of symmetry is it's exactly equal distance a point because it's symmetrical. So for my axis of symmetry, if I went over 2 this way, I have to go over 2 this way, and there will be another point. So let's go ahead and just graph that one right here. And now I can draw my parabola. It's going to come down and go back up. Okay, so now I've graphed my parabola. Let's talk about how all it changed from the parent function. So when we're looking at that, we have an a value. The a value is going to be positive, so it's not reflective, but it did give it a vertical stretch. So our change is a vertical stretch. And we can also look at, we have an h value. We also have a horizontal shift. So vertical stretch and horizontal shift. Now the horizontal shift was 2 units to the left and our vertical stretch was by a factor of 3. So by factor of 3. Okay, so that is the transformation of our graph.